I also want to make a quick video explaining this thing that I completely collapsed on in class for my late session that ends at 5:30. So there was this sine question, remember, in class. So there's this claim from this physics textbook that says that sine x is approximately equal to x near zero. So we talked about that in class. That's just because x is the linear approximation. And there was this claim that it's accurate to about 2% out to 20 degrees. Okay, so I tried and badly failed to demonstrate this during class, and I had remembered the question from the textbook. The question is actually number 40 part B in my textbook. And actually, looking at the question, it says use a graphing device to determine the values of x for which sine and x differ by less than 2%. So I have done that, and so let me show you what it looks like. The picture is terrible. I don't know how to make it look better. Also, a lot of you might have a hard time seeing this. So let me write on the bigger thing where you can actually see what I'm writing. The black line here in this picture on foo plot is x, and the red line is this function. That red line there is, whoops, it's sine of x plus 0.02 times sine x. Okay. And so why have I done that? Just because whenever the black line is beneath the red line, you know that the red line is within 2%. The black line is within 2% of the value of the value sine x for that x. So what we need to do is look and see where this intersection takes place. So let me zoom in a little bit. You can see that they're really close. You can use my intersection tool here, and I'm sure you can't see it, but oh, it's kind of a mess actually. Let me see if I can get a better number on the screen. So the intersection takes place at 0.3440. Right, so maybe this thing will give me a new page for me to draw on. And so I draw kind of an enlarged picture of what's happening here. I have the sine curve on top, so I guess I should draw that in red. And then the black line is crossing it at a certain point, and this intersection value has this intersection point here has x value 0.334 and then a bunch of other stuff. Okay, so let me just go back and double check on that. Yes, okay, 0.344. All right. So is that 20 degrees in radians? And it does turn out to be about 20 degrees in radians. You can see that 20 degrees in radians is about 0.35. So 20 degrees is equal to approximately 0.35 radians. Okay, and so what we've done is we found the limit of the x values within which x and sine x agree to within 2%, and the x value, which is the cutoff, is approximately 20 degrees, which is 35 radians. And so that's why that's true, I guess.